Welcome grade 10s to 12s to this great lesson we have today on Thursday, almost weekend, so just bite down, I promise it's almost the weekend, and today we are doing maths literacy. Thank you to Macmillan for proudly sponsoring our great show, and today on the show is myself, Megan, and of course Peter. How are you?
I'm good, Megan. Absolutely great. Folk, it's great to be back this afternoon. And when you see me, you should be very excited. Not because of me. I've got nothing to do with it. But like Megan said, when you see me, it means it's Thursday. And Thursday means it's quarter to Friday, which is a fantastic time of the week. And then the second reason you should be excited you're seeing me is because we're doing some good old mathematical literacy.
Can you tell me what we're actually doing today, though?
Yeah, of course. Today we're going to be looking at data representation. In other words, sometimes you get given a whole lot of data, all right? And sometimes you're asked to calculate the mean or the median or the mode. Well, today we're not doing that part, but what we're going to be doing is we're going to be looking at the data and showing how we can represent that data on different types of graphs.
Okay, wow. So grade 10s to 12s, I hope you're buckled in, hope you have your notes in front of you, and I'm going to tell you where to get them. And that is at mindset.co.za/learn extra with an X. And I'll be posting the fast link on for you in a jiffy, so don't worry about that. And also, I will be on the page, our Facebook page, which is facebook.com/learn extra. But also, if you want, or if you can, or if you have, please hit us up with a tweet on Twitter @learn extra. But unfortunately, my time is up talking to you, so Peter, take it away.
Okay, thank goodness. I thought you were going to take over the whole show.
Long time.
I kid you not. All right, folks. So, what are we doing today? Let's have a look here. Today we're looking at how we can use graphs to represent data or information. Now, what I want to spell out to you, whether you're in grade 10, grade 11, or grade 12, is there two different ways we can ask these kind of questions, okay? We can either give you a graph and ask you information which you extract from that graph, or we can give you information and say to you, right, now, you draw the graph. And that's exactly what we're going to look at today. Both looking at the graphs, getting information, and then hopefully we'll also have time to do a few examples where we get given the information and we're going to draw some of the graphs. Okay, so we're talking about graphs. And I thought the best way to start is to just remind you, if you're in grade 12 and grade 11, and maybe for grade 10 this is the first time you're coming across this, but just to remind our senior students out there on the different types of graphs. So let's have a look over here at our screen behind us. Now, over here on the left-hand side, we've got two. We've got one on the left and one on the right. Let's just focus on this on the left-hand side. We can see here that we have graphs that look like little bars, okay? Now, because of that, we call that a bar graph. So let's write it here so we don't forget, a bar graph. Okay, now let me just explain what that graph's about. Basically what happened is someone's gone and done a kind of survey, and they've gone to different households and said, how many of you have a radio in your home? How many homes have a computer? How many homes have TV? How many homes have a fridge? How many homes have a landline telephone? How many homes have internet? How many homes have cell phones? Okay, and they did that survey in 2 different years. The first year they did it was in 2001, and the next year they did it was in 2007. Now, folks, the reason we draw a bar graph, okay, is to work out or have a look at information pertaining to one specific year. So if you look here on this graph on the left-hand side, we're looking at the number of households that had radio, computer, or TV, fridge, landline, internet, or cell phone in their homes in 2001. On the right-hand side, we can see now that we're looking at the number of households that have radio, computer, TV, fridge, landline, internet, or cell phone in the year 2007. So we've got 2 different bits of information. And we'll draw single bars if we just want to focus in on 2001. So here, we just weren't interested in 2001. We're not worried about what happens in 2007. On the other side, we're focusing on 2007. We're not worried about what happens in 2001. Okay? So bar graphs, we're looking at specific information pertaining to 1 year or to one occurrence, as it were. Okay. Now, could I make a comparison between the years 2001 and 2007? Maybe we want to know, well, have the number of households who had internet in 2001, has it grown since 2007? Well, of course we can make the comparison, and we have to make those comparisons. Can we use bar graphs to make those comparisons? Absolutely. We can look here at a bit of information, and then we can compare it to 2007. So in 2001, we got 73% of households had a radio. In 2007, 76.6% of households had a radio. Let's look at the internet. I find that one interesting. In 2001, no percentage of people had internet in their homes. But in 2007, we had 18.6% of people had internet in their homes. Right. So we can make that comparison. But what we're going to look at now is what happens if I take the information from 2001, I take the information from 2007, and I slap that information together in one graph. Look what happens. We now land up with graphs looking like this, and we're going to call this a double bar graph. Okay. And guys, the name actually helps you, hey? Double. You can see we've got two graphs, two graphs, two graphs. But if you look at the graph, you'll see that they are two different colors. We have this kind of funny green turquoise color, and that would be, I'm just going to call it green. Why? Because I don't know how to spell turquoise. Okay, so we got green, and we're going to say green represents the year 2001. Then we have this orange color, and hopefully that's what it looks like on your TV screen, and we're going to say orange represents the year 2007. And this bit of information, saying the green represents 2001, orange represents 2007, we call that our key, K-E-Y. And guys, it's important to put a key down when we've got a double set of information. Otherwise, we're not going to know, well, what does green represent and what does the orange represent? So we've got to tell our examiners or our readers, guys, green means 2001. Orange means 2007. Now look how we've taken this information and we've put it together on the same graph. Why would I do that? I would do that to make the comparison between 2001 and 2007 and see if technology has advanced in those 6 years. So let's have a look at it. Radio has increased. Hasn't increased very much, but there has been an increase in the radio use from 2001 to 2007. Computer use has increased quite a bit. TV use has increased. Fridges, more people are using fridges. Okay. This is an interesting one, landline. Less people were using a landline in 2007 than what they were in 2001. Why do you think that was? Megan, why do you think?
You want me to tell you?
Yeah, do you know?
I think technology wasn't what it is. I don't think everyone
But there's been a decline in the number of people that are using landlines.
Oh, landlines.
Yeah, why?
Because we don't
look
need
at this.
them. We have cell phones.
Because more and more people are using cell phones. Okay, so cell phone usage has increased, and because of that, people saying, gee, I've got a cell phone, why do I need a landline? Okay, and internet has also increased. You'll notice here, let's have a look here, there is no green marking. Why? Because, according to our data, no one had internet in 2001. I don't know how true that actually is.
Oh, I was in grade 1, so I actually probably wouldn't even know.
Is it? That's kind of scary because, like, I was kind of old in 2001. All right. But in 2001, and guys, in fact, I must tell you, hey, I remember when internet first came into the world.
Really?
It was the weirdest thing. Okay? Because what actually happened was I went to teach overseas, and I left at the end of 1999 just to teach in a bit of an American system and British system, see what that was about. And so off I went. And just before I went, there was a friend of mine at the airport who was absolutely devastated I was leaving. Okay? And there she was, sobbing her eyes out, and she gave me her address and said, "Here is my address," and gave it to me. And I didn't look at it, and I took it. I said, "Thanks very much," put it in my pocket. And we got on in the aeroplane, and I flew off. Okay? And while I was flying in the air, I thought, oh, I must write this address down in my address book, otherwise I'm going to lose this piece of paper. And I took it out, and I thought, oh, shame. This girl is so devastated that I'm leaving. She's written absolute rubbish down.
Doesn't even make sense.
It made no sense. It said something like, I can't even remember what it was. Let's say abc@hotmail.com. And I thought, she hasn't even said what province, what code. This
South
woman's
Africa.
lost it. So I tore it up because it made no sense to me. Okay? So we've really developed quite a bit. And this data is showing us. Internet, we had nothing going in 2001. Oh, did you see that fly away? Okay, we had nothing going in 2001. In 2007, we had a lot more internet. Can you see how I've taken a bit of information and put them together to make a comparison? Now, there's another thing we can do with this information. Let's have a look here. I'm going to put my one bit of information on top of my other information. And we're going to call that now a compound bar graph. Okay, now viewers, I must just stress something. Okay. South Africa, the UK, and the American system. Depending what textbook you're looking at, some textbooks refer to this as a compound bar graph and refer to this as a double bar graph, and others do it the other way around. Okay. But we're going to call this a double one, and this bottom one here, we're going to call a compound bar graph. Now, why would I use a compound bar graph? Here we can see green represents 2001. Let's call that green. Green 2001, and we said our orange was 2007. Now, let's have a look at this. Why would we want to put information on top of each other? We would want to do that when we're more interested in the actual form of technology rather than who had the highest amount in what year. Okay, so here we're making a comparison between the different years, and for our compound bar graph we're making a comparison not so much between the different years, although we can still see it, but we're making a comparison more between which form of technology or which appliance is being used more in the homes. So when we look at that, you can see straight away, hey, radio is the most popular appliance, the least popular, internet. Okay, whereas looking here, it's kind of hard to decide which one overall is the most popular. Whereas looking at our compound bar graph, it's so simple to see. Now we can put that information in another form of graph. Let's have a look at this. We've now got a line graph. And with our line graph, I'm really coughing here today. I don't know what's wrong with me here. In 2001, we can see we've got this information and we've made little dots on our graphs and we've connected those dots with lines. Hence, we call this a line graph. Okay. 2001, 2007. Okay. Two different bits of information. The one graph we'd look at if we're only interested in 2001. The other graph we're going to look at is if we're only interested in 2007. Can we put the two bits of information together? Absolutely. Let's have a look at this. There is a bit of the same graph again, but now it's in the form of lines, and you can see that we have 2 lines. Remember, our green represents 2001, and our orange line represents 2007. And folk, you can get that in an exam, okay? Now, just this morning, I was dealing with a student called Zanelli. And Zanelli, I hope you're watching this, because I told you must watch, because you're going to learn a lot from it. And we were going through past papers, and we came across a question which actually had a double line graph. Okay? They didn't ask us to draw it, but they gave 2 on the same graph and asked us questions about it. Okay, there's one more type of graph we've got to look at, and that's this whole concept here of and we call this a pie chart. But I think I'm going to talk about pie charts after the break, because I think it's time for a break.
Time for a break. Well, that's no problem. Grade 10s to 12s, we will see you right after the break. Don't go anywhere. Welcome back, Mindsetters. Hope you had a great break, stretched a little, got what you needed to, and now ready to tackle the rest of the show. Please, guys, send your questions through, send your comments. That's what we are here for, and we are here to help you learn more, learn extras. Don't forget, okay? I'm really here, I promise. So, just wanted to let them know, Peter, before they forget.
And folk, that's important, hey? We're actually here for you. So if I'm going through something and you don't understand it, or you've got a question about something, please ask Megan. Megan, how do they ask you this?
You just post on our page. You just say, you go onto the page, facebook.com/learn extra, and then I'll ask Peter and we can sort out your problems, I promise. It's as easy as that.
Fantastic. All right. So, folks, we're looking at how to represent data. We came up with this whole thing that we could have bar graphs. We could have double bar graphs, which are still bars, but they're next to each other. We could have compound bar graphs, which are still bar graphs, but 2 bits of information above each other. Then we looked at line graphs, which is when we've plotted information as dots and then joined those dots with straight lines. And then just before the break, we said we could also get something called a pie chart. Okay, and this is what is known as a pie chart. Now, we've got 2001 information and 2007 information. Now, sorry, geez. I don't know what I've eaten today.
It's okay, it's fine.
So in 2001, you can see how many people use radio, computer, TV, fridge. You can't get the exact figures from it, though. Okay? It's quite hard to read it, but it gives you a basic understanding of everything that's going on here. So just by looking at that, you can see, well, in 2001, a lot of people used the radio, and not so many people had TV. Whereas if we look at 2007, we can see here that the percentage of everyone using radio has kind of decreased a little bit because all the other appliances have increased a little bit. So in other words, what a pie chart's doing, it's looking at all those appliances, and it's now saying, of all the appliances, what portion of it belongs to radio? Over here, what portion of that belongs to radio? Can I take my information from a pie chart, or take 2 different bits of information and put it into one pie chart? Guys, I actually can't use a pie chart to make a comparison. Okay, that's the only huge downfall with this pie chart. I can't take information from 2001 and 2007 and put them into the same pie chart and try and make a kind of comparison between it. Well, we can't do it in Mathslit anyway. We don't even look at that. Okay, so, but what I can do, and this has come up in a past paper, if we look here, I've drawn 2 circles. Okay. And I'm just going to kind of, let's make up an example here, right? Let's say I've got tiny little beads. And I've got red beads, green beads, yellow beads, and blue beads. Okay? What I can say is I've got some green beads, and Megan, you've got green beads.
Okay.
Okay? we want to know how many green beans do you have and how many do I have. Now, this represents the total number of green beans. Now, we've seen a paper where an examiner has done something like this. And I'm going to try and draw a straight line, as straight as I possibly can. Let's have a look. And let's try to draw it again now. Okay, and then we're going to do this. So now, what's this graph showing me? It's showing me the total number of red beans, blue beans, yellow beans, and green beans. And then I've got two lines coming off the green beans. So in other words, I'm saying this graph here, pie chart here, represents the full amount of green beans. It only shows green beans. But we're going to divide it again to show how many green beans Peter has and how many green beans Megan has. Okay? Guys, that came up in one of the past papers. It wasn't about beans, it was something else. But it's quite a complicated kind of question. Let's look at it again. So here we're showing the total number of green beans, and here we're dividing those green beans and saying these ones belong to Peter and these ones belong to Megan. The other thing we've got to remember about a pie chart, folk, is this, that there are 360 degrees in a circle. Got to remember that, and you'll see why later on when we do some examples. Okay. So, we're going to go through all this again, but what we're now going to do, and there's just one other graph I've got to just quickly explain, because this does cause a bit of confusion, so let's have a look at it. This graph over here, we're going to call this a histogram. Oops, let's write it again, sorry.
It's okay.
My hand kind
He hasn't
of goes...
been here for 3 weeks, guys. We'll just accept.
Histogram. What is a histogram? A histogram has got like bars, but I don't like calling it bars, but they are like bar graphs, but the bars are touching each other. And it's talking about a continuous set of information. In other words, if we look at the bottom here, we've got something called time in minutes. I've got from 0 to 10 minutes, from 10 to 20 minutes, from 20 to 30 minutes, from 30 to 40 minutes, 40 to 50 minutes, 50 to 60, and then this is a amount above 60 minutes. All right, so it's time. Now, if we look here, we can see that we've got around about, about 11 and a half people, and I'm just going to make up a story what this graph represents, because I don't know what the real question was. But we could say that guys are sitting down, they're going to write a quick maths lit test, okay? 11 people finish, so it can't be 11 and a half, because you can't have half a person, even if their brain is a little bit funny. Okay, so we got 11 people who finished the test within 10 seconds. We don't know if they did it in 1 second, 2 seconds, 3 seconds, 4, but we know from 0 to 10 minutes, rather, not seconds, they completed the test. From 10 to 20 minutes. So we now had 22 people who finished this test between 10 and 20 minutes. It could have been 10,5. It could have been 19,5 minutes. Okay? It could have been 19 minutes, 59 seconds. But that graph is showing us how many people finished their test within a specific period. It's not telling us exactly what time they finished it. It's giving us a range of time. So we tend to use histograms when we've got a range of data, okay? And it can be in minutes, it can be height, it can be in kilometers, it can be people's weight, okay? But it's continuous data. This is all minutes. Before, we had yellow, red, green. Okay? Here we've got all the minutes. All right? Do you understand what a histogram is? So a histogram is looking at a set of data. All right? And each bar represents a certain range of that data. Now, let's have a look at this next thing. What we've got here is I've got a bit of an experiment to do, and we are going to do some practical work. Here I have a box of sweets. Now, we're not allowed to advertise, so I can't tell you what these sweets are, but I'll just tell you this. They're little color sweets, and I'm a very smart guy. Okay, so we've got these sweets here. I've got a box, and Megan, I'm going to give you a box. There we go.
Box.
How wonderful is that? Rattle your box. Okay, what's the problem?
I think James ate all of them.
Okay, our producer ate all those Smarties. So there's nothing in that box, but fear not, because what I've actually done is I've emptied your box into 2 different bowls.
Oh,
Okay.
sorry, James.
So I've got a bowl of Smarties, and I'm going to come up here so you can see those Smarties. There they are. Can you see them? I hope you can. All right, cool. So there they are, and what we're going to do is we're just going to focus on my Smarties.
Okay.
Okay, we're not worried about your Smarties,
Not more.
just my Smarties, but you're going to help me anyway.
Okay.
So I'm going to hand you the bowl of Smarties, and in there are 3 colors. Would you agree? What colors do we have?
We have yellow,
We have yellow,
purple,
purple,
and green.
and green. Absolutely. Okay. And what we're going to do is, Megan, you're going to tell me how many of those Smarties I've got, and I'm going to put them on this bar chart here.
Okay.
Okay. So I've got, and I've already labeled them, 1, 2, 3, 4, 5, and 6. I've got purple, I got green, I got yellow. So what I'd like you to do is I would like you to tell me how many purple Smarties I've got there.
4.
4. Okay, you can't eat any because I know the answers, all right? So there are 4. So we're going to draw, and I'm going to try and be quite clever with this technology. There we go. I've got 4 Smarties. Okay, how many green Smarties do I have?
3.
I've got 3. Shame, that's quite depressing. Okay, so I've got 3 green Smarties. There they are. And how many yellow?
5.
Oh, wow, that's fantastic. Okay, so we've now got 5 yellow Smarties. Right. Folk, let's have a look at this. First of all, I got different bars. Okay? Every bar represents my colors. So purple, you can see straight away, I've got 4 purple Smarties. Green, I got 3. Yellow, I've got 5. When I draw a bar chart, guys, there's certain things I've got to put down. Let's write down what they are. First of all, I have got to give my graph a title. And the title's going to be Pete Smarties, or the number of Smarties Pete has, okay? Number of Smarties, oh, I'm not allowed to say that word, hey, because we're advertising.
Number of nice colored sweets.
Okay, number of sweets Pete has. Oops, Pete. Okay. Now, that's the title of my graph. Your graph has got to have a title. Then I've got to tell the examiner what these numbers represent, or what these words represent. On the side here, I've got the frequency. What's another word for frequency? The number, eh?
Yep.
So the number of Smarties I have, or the frequency. And at the bottom here, I've got the colors of Smarties, or colors. Okay, so those are 3 things I've got to put down. I've got to say the title of the graph. I've got to give what is my vertical axis. What is my horizontal axis title? Guys, you're going to get marks for that at the end of your matric year. So if for some reason I haven't put down the title, or I haven't told the examiner what those numbers are, or I haven't told the examiner what this PG and yellow is, and I would probably write purple, green, and yellow. I'm just being lazy because we're running out of time. But I've got to tell the examiner that, because when I tell the examiner that, I'm going to get marks for it. Okay. And then I've plotted how many purple, how many green, how many yellow. Now remember, guys, remember, this bar graph is just about me. My Smarties. It's got nothing to do with Megan's Smarties at all. Okay? We're not interested in Megan. Well, we are, but not her Smarties.
Not
okay? Because she's not smart at all. But this is about me. Now what we're going to do is we're going to make a comparison. So Megan, now what's going to happen, I want you to give me back my Smarties because I actually don't trust you at all. And I'm now going to give you yours. Okay? So there now and I kind of dished them out equally.
Not
all right?
really.
So I've given myself Smarties, and now I've given you some.
Okay.
So here we go. And now what we're going to do is, I kind of cheated just now. During the ad break, I drew this up. So do you remember here, we've got Pete Smarties, number of purple, number of green, number of yellow. Okay. Now what we're going to do, now we are interested in the number of Smarties Megan has. So what I'm going to do, and hopefully I'm going to get this right with this technology. What's your favorite color, Megan?
My favorite color would be red.
Would be red. It's junior orange, so your favorite color today is green. Okay, cool.
Okay.
Right, now, Megan, how many purple Smarties do you have?
2.
2. Okay, so Megan has 2 purple Smarties. Right. How many green Smarties do you have, Megan?
3.
3. You've also got 3 green Smarties. Fantastic. Okay. Megan, how many yellow Smarties do you have?
I only have 1.
Oh, shame, that's
Oh.
it. Okay, so she's only got 1 yellow Smartie. Now, guys, from this graph, can you see what we do? We're making a comparison between Pete's Smarties and Megan's Smarties. What do I have to do on here? First of all, I've got to have a title. What would my title be for this graph? It would be the number of Smarties that Pete and Megan has. Here, it's going to be frequency, okay? And my horizontal here is still going to be colors. But now I've got to add one more thing. What must I add? Can you remember? It's called a, let's write it down, the key. Okay? And I've got to show that orange is Peter's Smarties and green is Megan's Smarties. Okay. And guys, I'm just using P and M because I know we've got to take another ad break. So I'm just going to, but you would write Peter and you would write Megan. Okay. So here we're making the comparison between who's got what Smarties. What we're going to do after the ad break is this. We're not going to be interested now as to who has more Smarties. We're going to be interested in as to which color was the most popular and which color was the least. But we'll do that after the break.
Thank you, Peter. Well, I'll just look at my little Smarties and wish I could eat them, but we'll see you guys right after the break. Welcome back, Mindsetters. Hope you had a good break. Calm down, relax, listen to what all Peter said. But now it's my turn for like 2 minutes just to tell you about something we have running here at the Mindset Studios. Because, you know, we always have something, and lately we haven't. So now I have something to tell you. I'm sure in some point in your life there's been a teacher that's impacted you, made your dreams come true, or made it possible to think your dreams can come true. And now we actually have a competition. I'll post the website on your Facebook page or on the Mindset Facebook page because it's got too many PHs and WWs. So I'm not going to say that whole thing for you right now. But it's called the Stars in Education Awards. And if you think your teacher should be a star in education, as they'd like to say, then I think you should enter them and they could stand a chance. So I'm going to post that on the page right now. Go and click on the link and enter one of your favorite teachers who have impacted in your life some way or another. Just like Pete's has impacted all of us, right?
Oh, that's so
I
nice of
know.
you. You obviously want your Smarties. Clearly,
How
that's
did
all
he
you're in
know?
here for. All right.
Gosh.
Okay, folks, thanks. Sorry, have you finished? Or
Yep,
can
no.
Okay, because you said 2 minutes and you're not quite 2 minutes.
Yeah,
so
that's
it's-
even better. Now I give you more time.
All right, folks, so just before the ad break then, we were looking at different color Smarties, and we looked here at how to draw a graph, and we call this a double bar graph, making a comparison between the number of Smarties Peter has and the number of Smarties Megan has. And we said Peter is represented by the orange color, and Megan is represented by the green color. From this graph, we can see Peter has more purple Smarties. Megan and Peter have the same number of green Smarties, and Peter has more yellow Smarties than Megan has. So here we're looking at who has more Smarties, Peter or Megan. Now we're going to draw a graph, and we're going to call this a compound bar graph. We're going to draw a graph now saying, okay, what color is most popular? So let's have a look at my next graph. And again, during the ad break, while you were sitting down and having coffee and doing weird and wonderful things, I was busy drawing or getting this graph ready. Here it is here. Okay, so for this graph, again, I've got a title, the number of Smarties, frequency, okay, and then at the bottom, I've called this my different colors. Remember, I've got my key where green represents Megan and orange represents myself, Peter. By the way, Megan, I'll never forget your name. You know why?
Tell me.
Okay. Because we used to have a little piggy called, no, I'm joking. Because my brother has just got engaged to a woman called Megan.
Megan. Do you know what my name means? No.
No, what's your name?
Pearl.
Pearl.
Yeah. So now
Okay,
you
that
just
doesn't apply to my future sister-in-law. All right, so let's have a look at this. Now, we're now going to draw the bars on top of each other. Okay. So again, and hopefully this is going to come right, can you tell me how many pink Smarties you had, or purple Smarties rather, you had? Megan?
Oh, right. I had 2.
2, okay.
Yeah.
What's 4 plus 2, Megan?
6.
6. All right, now look here, folk. I'm going up to 6. So what this basically means, oops, I seem to have made a little error here. Let's try that again. Okay. No, I've done it again. Let's try again. It's this technology.
So
Okay.
2.
There we go. When you look at this graph, you can see that I had 4, Megan's had 2, so 4 plus 2 takes me to 6. But the graph is still showing, though, that we've got a total of 6 pink Smarties, 4 of which belong to Peter, 2 of which belong to Megan. But we're not so interested in how many Peter has and Megan, but rather how many pink Smarties we have. How many green Smarties do you have?
3.
3. Okay, so 3, she's got 1, 2, 3, there are her Smarties. Okay, I don't know why I'm getting the second block here. It shouldn't be at the bottom there, sorry.
Just pretend.
Okay, and yellow, you've got a whacking total of?
1.
Of 1 Smartie. Okay, there it is. All right, so you can see that how many purple Smarties do we have in total?
6.
Absolutely. How many green?
6.
How many yellow?
6.
Absolutely. Okay. That was just a fluke, by the way. It wasn't meant to be like that.
Okay.
All right. So this graph now is showing us the most popular Smarties that we have. All right. Can we draw this in a pie chart? Absolutely. But first, we can only draw a pie chart that belongs to Peter. We can only draw a pie chart, a different one, that belongs to Megan. Okay. Now, our next thing we're going to do, hopefully, yeah, here we go, is we're going to look at a few questions which involve some of these charts, okay? So I have a bar chart here, and let's read this. Mrs. Smith, a quality controller for a toothpaste manufacturer, inspected 400 tubes of toothpaste. This comes from a matric pass paper, by the way, okay? The number of faults of different types is recorded in the graph below. So what actually happens is this. We've got someone who's doing a quality control, okay? They're checking all the toothpastes that come past her. And 400 come past. And of the 400, she notices that 12 of them have a specific fault. And we're going to call it fault A. Now, that fault A could mean anything. Maybe it means the lid isn't screwed on properly, okay? We've got 6, which are fault B, okay? What does fault B mean? Well, we're not sure. Maybe it means the base of the toothpaste is not closed, sealed properly, and so a little bit of toothpaste is oozing out. We've got here 2 with fault C. Fault C could mean maybe there's not enough toothpaste in the tube, and so the tube's looking all funny. All right? We've got 2 with fault D. I don't know what fault D could be, but there's some fault. And E, we've got 1 fault. All right. So looking at that, we can see now what's our major problem. Our major problem in manufacture is fault A. And what did we say fault A was? We made it up. We said the caps aren't screwed on properly. Okay. Which is the least of our problems? Fault E. Now, let's see the kind of questions that came up about this. First of all, what was the total number of faults found in the 400 tubes of toothpaste? Okay, so remember, 400 tubes came past, and we found 12 faults, 6 faults, 2 faults, 2 faults, 1 fault. What's that going to give me? 12, 18, 20, 22, 23 faults. Sure, that's quite a lot of faults when you think there are only 400 that we're looking at. Okay, so my answer here is there are 23 faults. Next one. The company wants to improve its product by reducing the number of faulty tubes it makes. Which one of the fault types should be fixed to give the greatest improvement? Okay, well, obviously, folk, A, we got a huge problem here. If we can fix up A, we got 12 of our problems gone. That's fantastic. If we fix up B, we've only lost 6 problems. C, we've lost 2. D, we've lost 2 problems. E, we've lost 1 problem. So if I can work on fault A, hey, we're on to a winning streak here. Okay, next one. Oh, so it's going to be fault A. Next one. A tube of toothpaste is chosen at random from the sample of 400. Okay, so 400 toothpaste come past, we just grab one. Close our eyes, grab it. Okay. Now, what's the probability that the following will be chosen? Now, folk, look at this. From looking at bar graphs, we're focusing on bar graphs. Suddenly, there's a probability question that comes out of it. And that's the great thing about MathsLit, isn't it? That we can overlap all our different sections of work. Okay. Not like that horrible subject, maths. Maths, if you're doing factorizing, you're factorizing. If you're doing simplification, you're simplifying. If you're doing, I don't know, trigonometry, you're doing trigonometry. But MathsLit, we take all the topics and we mix them up, because that's what real life's really all about, isn't it? So, what's the probability that we will take a fault B? Now remember, there are 400 toothpaste tubes. So out of the 400, how many had fault B? So let's have a look at it. 6 of them had fault B. So we've got 6 out of 400 that had a problem. Okay, and when we simplify that, we're going to get 3 out of 200. Here's a good one. How many, okay, what's the probability that we grab a tube of toothpaste and it has no fault at all? Well, let's have a look at this. No fault at all. Now, we know there are 400 tubes of toothpaste. How many of them have a fault? There are 23 that have a fault. So if there are 23 that have a fault, how many of them don't have a fault? Okay, well, we're going to say it's 400 minus 23. And 400 minus 23 is going to give us, what's it going to give us? 377, huh? 377 over 400. That's the probability of choosing a toothpaste, okay, that doesn't have a problem with it. Now, folk, they haven't told us how they want the answer. And you know, when you go to probability, you can write it as a decimal fraction, as a common fraction, or as a percentage. This question hasn't told us how to write it out, so we could just leave our answer as 3 over 200 and 377 over 400. Okay, let's go on to our next question. Next one. Hopefully we'll get there. Let's just wait for the page to turn. Right, question number 2. I don't know what we've got here. Done, close, right, yeah. Question 2. The following data in the table shows the percentage of gold medals won by countries hosting the Olympic Games compared to when they attended the Olympic Games in another country. All right? So what someone's done is they've done a bit of research and they've said, right, let's look at how many gold medals a country wins when they're hosting the Olympics. How many do they win when they're not hosting the Olympics? And what do I mean by hosting? It means the Olympics are held in their country. So here we can see, for example, Australia. When the Olympics was held in Australia, they got 31 gold medals. When it was not in Australia, they won 30. The UK, they won 13 when they hosted the Olympics, and they won 30 when they were not hosting the Olympics. And so it gives us a whole lot of data. Now, it says, use the table above to answer the following questions. How many countries, when hosting the Olympic Games, won more gold medals compared to when attending an Olympic Games in another country? So let's have a look at this. Okay, so when it's another country, how many more? That is more, oops, let's just get a pen here quickly. Right, that is more, that's more, that's more, that's the greater one, that's the greater one, that's the greater one, that's the greater one. Now, how many countries got more medals when they were not hosting? There were 2 countries, okay? What's that actually tell you? It kind of tells you that people are more inspired, as it were, when they're doing a run or a throw or a jump or something in their own home crowd. It's like when you're watching a game of soccer, or you're watching a game of rugby, or when you're watching a game of hockey, okay? You tend to find that the home team, in other words, if the Sharks are playing, and the Sharks belong to Natal, so if the Sharks are playing and they're playing in Durban, they tend to have a bit of an advantage because they've got their home crowd with them and encouraging them and saying, come on, you can do it, okay? When the Sharks play in another province, they tend to find that most of the spectators are booing them or saying, you can't play properly, you're rubbish, boo, okay? And so they're not as inspired as they would be if they were in their home country. And that's what this is showing with our gold medals. Now, how many countries that attended the Olympic Games in other countries have a higher percentage of gold medals as part of their overall total of gold medals compared to when they were hosting the Olympic Games? Now, folks, I'm running out of time here. I'm watching. We've only got about 2 minutes to go. So I'm going to skip along here. I kid you not. And I'm going to go all the way down here. Draw a compound bar graph below to represent the information of the percentage of medals won by each country when hosting and not hosting the Olympic Games. Okay, so in other words, guys, what this question is saying is this. Take this whole table, okay, take it and slap it in to some form of a graph so that just by looking at the graph, I can pick up all this information. We're really not going to have time to do it, but I'm going to show you how we go about doing it. Let's look at the first country. The first country we're going to look at is Australia, and I'm going to ask you to remember this, please. Hosting, not hosting, 3130.
Okay.
Cool, got it?
Yeah.
Okay, great. Now, let's go down to our set of axes here, and we've being given a set of axes. Normally in an exam, even if it's a matric exam, an examiner won't really ask you to draw a graph without giving you the set of axes. So it kind of helps you, okay? And with the set of axes now, we are going to plot the medals that have been won. So what are we going to do? First thing we need is a title. So we're going to write down the title, and what kind of title would be good here? Well, we'd probably say the number of medals won in the Olympics. Okay? Then over here, we're going to have our frequency, and we had a question posted by a viewer, didn't we, Megan?
Yes.
And they asked, can we swap frequency and, in this case, it's going to be countries, okay? Can we swap it around? Well, actually, we don't. And we can't, all right? Why? Because the number of medals depends on which country we're looking at. So we call this our independent value, and our horizontal we call our dependent value. The frequency depends on the number of countries, okay? A better way to remember it, and I just say, if you can't remember all that, because that's quite a lot of jargon, then just remember that our numbers always goes down on our axis. Guys, I cannot believe we've run out of time. Maybe we can carry on next week. I'll see you next week.
Okay, no problem. Thank you, Peter. Thank you, Mindsetters. Thank you, Macmillan, for proudly sponsoring our show. And Mindsetters, we'll see you next week.